So, in this session, we will explore similarity search, also called visual search. So, given basically an image of a style, how would we find similar styles? What does even AI consider to be similar? Personally, I think this is super exciting because it can be applied in so many different ways. It has so many applications and it can be combined with various types of suggestions and recommendations, which we'll explore today. So, Stefan, please take us through how this technology actually works.
Of course. So let's maybe start with the end result first. So what we want to achieve in the end. And here we have our internal tool showing a selection of Hawaii shirts in that case. So let's have a look at this one in particular. And what we can see here is that for this Hawaii shirt over here, we can actually show similar items. So that visually looks similar to this shirt. So I can also select one here. Let's pick, for example, this one. This one is actually quite close, I think. Then we see this one, and then again we get similar styles for these, and we can basically play this forever. It's quite cool. And of course, where you can then use it in the end. I mean, if you think about your e-commerce store or on a touch screen in the store. So let's say you're looking for this one and this is out of stock. Now you want to have something to recommend as an alternative that is somewhat that style or maybe even exactly that style, just as slight variations. And this is, for example, what you can use this for. There are also tons of other things. We will talk about them probably in next episodes, where we actually use similarity search under the hood to achieve even more complex things. But today, I think we will just stay on that topic a little bit.
Cool.
All right. So now, of course, the question is, how do we get here? So for that, we have to dive a little bit more into the technical parts behind first, to give a bit understanding, because it explains a bit later when we actually try out some things, like why we see some things and why we don't see maybe some other things that we would expect.
We should probably say that it's probably worth staying through a couple of minutes here now through these technical aspects, because in the end, I believe we will actually showcase and demo quite some interesting ways of figuring out what and how to apply similarities.
Exactly. That is what we are certainly going to do. So I just want to dive first a bit into the tech under, because this is generally a repeating pattern. So a lot for the other things we're also going to talk about also later, semantic search, these kind of things, they in the end work all very, very similar. And I think that's why it's actually good to, at least on a high level, a bit understand what's going on here. So if we talk about similarity, then usually one term that always comes with it is called embeddings. So what is an embedding? In the technical sense, you can imagine it as mathematically a vector, basically a lot of numbers. And if we have an image, and then we have an AI model, machine learning model, and then we take the image, put it through the model, and what the model then outputs in the end is then what we would call an embedding, which is essentially simply a lot of numbers. And what these numbers describe are visual features of that image. And that in the end makes them comparable. So now the question is, what is a visual feature? And the tricky part here is that the way how such a model thinks, in quotes, is a bit different from how we think about images. But for example, to give you an example, what a feature could be. Let's say you have an image and you look at the image and then you would say, okay, this is a very colorful image. Then you have another image and you say, okay, that's a very just gray image. So here you could say sort of the colorfulness, that is a feature of that image. So one image might score very high on colorfulness and another image might score very low on colorfulness. And then you have a feature that you can compare. And that way you can say, okay, this image is more similar to that one because it's also colorful than to another image. So colorfulness is now one feature. And what happens here is that it looks actually at a lot of different features in parallel. So potentially hundreds or thousands of different. And
how do you know what type of features to look at? I mean, colorfulness, or that it has certain shapes. I guess also a feature would be that it looks like a jeans or something like that. So how do you actually figure out, and how does it figure out like what type of features to look for?
Mhm. That is exactly the magic that we don't know. That is basically what the model figures out on its own. That is essentially the idea behind learning,
Mhm.
what a model does. So you basically give the model a lot of examples. Basically, what we talked about the last time when we talked about classifiers. So then we have the model, we give it a lot of images and say, okay, here are images of jeans, here are images of t-shirts. Look at them, and then it starts processing them. And then what it does, actually, it figures out those features on its own.
Mhm.
So basically, it tries to figure out what are the things that make this over here different from that over there. And that's why I actually brought up this image here, just to make that point that, I mean, here, for example, you would see a visual representation of some of those features that this particular model here basically extracted. And if we as a human look at it, it's like, okay, what is this? For us, it does not really make so much sense. So when we think more in terms of, okay, this has colors, it's bright, it's dark, stuff like this, the model figures out other things. And in the end, it's also not that important what that actually is. As long as in the end, it gives us this embedding, and that is in the end all we need, because then based on this embedding, we can compare images. And this is basically what we're going to do.
Mhm.
So another thing which makes it a bit harder to kind of think about it is that these kind of embeddings are, well, it's a lot of numbers. So usually we talk about around, let's say, 1,000. Sometimes, depending on the model, you might have 1,500 different dimensions, which makes it hard to kind of reason about it. But you can, just to explain this, often, if you now imagine, okay, we would only have 2 dimensions. There are actually ways how you can sort of break that down, this big embedding, into like very two-dimensional ones. And the advantage here, just for us to understand it, is that we can then actually draw it. So we can draw it in a coordinate system like we have here. And now each dot here would represent, let's say, an image of, I mean, here in this case, these would be images of cats, this would be images of dogs, cars. And here we put each of these embeddings that we have for this individual image, we put that into the coordinate space. And what you now just visually see is that all the images of dogs, they are kind of close to each other. And then over here we have another group, and here are the cats, and here are the cars. So this is conceptually how this works. Technically, I mean, as I said, there are many more dimensions, so it's a bit hard to imagine. But the math behind is still very much the same.
So I mean, what we basically see here is 2 dimensions or 2 axes, the x-axis and
Mhm.
y-axis, and you basically plotted one feature is 1 dimension, if I understand it
Mhm.
correctly, and
Mhm.
if you have, what did you say, 1,500 dimensions, is that
Mhm.
correct? So
Yeah,
there would basically be an x, y, z, and then 1,497 more axes,
exactly.
and
Exactly.
and of course each of these axes will describe one particular feature of this image, and then the more similar you will have, in the end you will basically have one vector that takes that into account and then finds basically similarities that way.
Mhm. That is exactly right. And
All right.
although in the actual data it's much more dimensions, but still the math behind basically the vector math is the same. So that we can also show here. It's kind of interesting if you think about it. So here, for example, if we would have embeddings for man, woman, and then you have boy, girl, then you can see they are, I mean, man and woman, they are on the age level, they're basically the same, but on the gender axis, they have the same difference like you have between boy and girl. You have the same difference between man and woman.
Mhm.
And this way, we will actually try that later a bit. You can basically combine vectors as well. You can say, okay, I want basically this vector for the man, and then I add a bit of gender to it, and then I basically end up over here. So in the same way, you can also do that with images. You can basically use the embeddings of several images and combine them, and then you basically create a new embedding out of that. which has then features of that image and the features of that other image. So just.
But usually it's not that clear with these features that it would say on one dimension is boy or girl. It's usually like on one dimension it would be like if it's edges or rounded shapes and God knows what type of features that it decided the AI model to extract, right?
Exactly. So a lot of these things, they are nice in theory, but then when you try to actually use them for real, you also notice, that there is some often, it's in the details. But we will talk about that later when we actually have some more visual examples. I think that's better to discuss them. So here we see again, so let's say we have two images, then here we basically put them through a model. I mean, they're kind of different models. So we will later use two different ones just to see a bit the difference. But there is a lot of different models generally to choose from. What they have in common, though, in the end, as I said, you basically get an embedding, which is technically just a list of numbers. And now the question is, so we discussed this part. Now the last part is, okay, now how do we know practically that this embedding is the same as that or similar to this embedding? Exactly. And that is where cosine similarity comes in. Again, another fancy technical term, but what it basically means, I mean, in a nutshell, again, we have here, this is the vector for a cat, and here's the vector for a dog. What cosine similarity measures is basically the angle between them. And that is important in terms of vectors because it doesn't matter really how long this vector here is in the end. It matters just basically how far they are spread apart. This is essentially what cosine similarity measures. And this is important because it makes it a bit more robust. So you can imagine, I mean, here I have actually some examples. Here's an image that has a grayish background, and here I have an image that has a white background. So you would say generally that often doesn't really make a lot of difference because our focus is probably on the person and on the shirt, not so much about what color the background is. So if you use cosine similarity, then it, for example, means that it matters less, for example, differences in brightness, these kind of things. It's more robust in that sense.
Because it takes into consideration many more features, many more dimensions. Is that the reason that one dimension in particular does not impact as much?
Yes, or let's say the extent of how much is not necessarily that. Let's say it's more. It can still see a lot of similarity, even if this dog here, let's say, is a bit darker than that cat. So that is sort of like what it does. All right, that was a long talk about embeddings and vectors and stuff. So let's do something more practical. I've prepared a lot of images. So let's just start with this one. And I get the link to that one. And then I have prepared a little tool just to try out things. So now we can give this image as this is our source. So what happens now if I press enter? What happens now in the back is, well, it actually takes this image and creates that said embedding. And then we have a database with a lot of different images and all the embeddings, and then it basically compares the embedding of this image with all the embeddings that we have of all the other images. And then it will show the ones which are, well, the closest.
So it's currently loading. Is it because it takes time to create the embeddings?
Yes. So this one, what I'm showing you, I made it just for the purpose of this recording here. So it's very experimental and it's not exactly optimized for speed. And in the back, it needs to boot up a machine learning model right now. In production, I mean, especially these kind of searches, they can actually be very, very fast. And I mean, if you remember from here, if I select one, then that happened also very fast. So let's look at the results. Also to mention here, there is on the, you basically have two groups. So on the left, we see clip. Clip is the name of a particular model that we used here. And here is another one, which is actually a model that we used the last time for the classifiers.
Mm-hmm.
So on first impression is maybe they are pretty similar here. So the first two images, the most similar ones, they are actually exactly the same. So that's good.
What we should just mention here is that the images or products that are shown under clip and swing, these are images that we have from one of our customers, which we have already pre-processed, and we've extracted the embeddings, and then we have a database of all of the styles, like thousands and thousands of styles. And out of those styles, we now want to see which ones are similar to this particular image that came from, let's say, nowhere.
Exactly. So in the back, we have tens of thousands of images that we now compare this one to. And these are the results. And then also, if you look closely, you see there's a number. And this number actually expresses the similarity. So the max it can get is 1. 1 means it's technically exactly the same. And then, well, the lower the number, the less similar it's considered. So now if we just maybe scroll through it a bit to see also a bit like where it now starts to differ maybe. So you see over here in the clip group, now already we see some things emerging that are the color, especially I think is different. It sticks out that this is now, it has now suddenly a brown color in here. While on this side, it's all still very green. And I mean, that starts to actually get worse. We will discuss why that is a little bit. I think I will just quickly try also the shirt here.
But one thing before you change that I think is worth mentioning here, this is a feature that we use as you may also like recommendations in our in-store solution and the Sile application. And it's not always necessarily that you're looking for, I looked at this and now I want something that is similar. But what does that actually mean, right? I mean, it obviously figures out that there should be a row in the middle. It figures out to the best of its ability that it should be green. But then, I mean, this is obviously a sweatshirt. Then we have, or hoodie, but then we also get recommendations of a sweatshirt, right? And so it's not as limited to traditional business logic where someone would have to make up a rule saying like, if someone clicks on this product, then only show me products from that category. Let's say hoodie sweatshirts. I mean, sometimes it does not make sense because there could be a sweatshirt, there could be even a shirt that is very similar in many aspects to the one that you're just looking at, and maybe you would be actually very interested in those things. So I think that is very interesting that it can actually pick up features, and to the eye it kind of seems off in terms of this fourth item, which is white, gray, and so on. It doesn't have any green, but obviously it's within the same family. It's related somehow.
Yeah, that's true. And also there, it's important, I mean, that these models, thinking is it's not exactly what's happening, but how they basically what
Reason.
kind of features that's what I was thinking, but they're not actually reasoning, but they respond differently to different kind of features. And it will be, I think, more clear. I have some more extreme examples than just like fashion items. Maybe I can already say clip generally, I would say, tends to sort of, again, think more in abstract concepts. While this one over here is more really on it's more on the visual looks of a picture, let's say like this. So let me just try another one. So here, again, first is very similar, but then you see on the left side that, more also different colored images come in. So, and that is, to some degree, you can basically explain it. It kind of sees the concept more of, okay, I got it. Here's a t-shirt, and secondary, maybe the color, but generally it's more, okay, it's a t-shirt in that kind of shape. While on this side here, it's more also pays more attention to the color in general. So now let's maybe do something a bit more extreme. So, and I will skip this one, but obviously, of course, that also works with model images. But now let's go for this one, which has absolutely nothing to do with fashion at first. So let's see what happens. All right, so now we already see it's quite different to start with. And what's interesting, I think, is that here, I mean, you could say that is maybe an image that people would associate with concept of, let's say, outdoor, maybe hiking, nature, adventure, these kind of things. And this is what here on the clip side, you actually see it picked up on. Also here, actually, I think, yeah, you could say that might actually be in Iceland. I don't know, actually, but I think there you can find scenes like this. So here it actually figured, or it shows us something from Iceland. So it's more on a kind of higher level concept that here it kind of connected these two. Or here you see this off-road vehicle. And generally on this side, you see a lot of, let's say, generally outdoor jackets, gear. While if you look on the right side, this model here, the first images, they are different. And actually, I think if you kind of look at it and just pay attention to the colors and shapes of it, then you would say, though conceptually, they don't have anything to do really with outdoor. But here it's more about the combination of colors and shapes maybe that you can find in this image as well. So this kind of white, pink, reddish patterns, this is what you see here as well. Also over here and here. So this is more what this kind of model picks up on. It's more kind of the, like very much closer to colors and shapes, while this is more about general concepts. And this is also what we will now even see more. And this also brings us, if you remember the part before when I talked about the man, women, boy, girl kind of thing. So when you combine vectors. So this is now actually what we can try here as well. So here, let's start first with the shirt. So here, the shirt alone, yeah, not much surprise. I mean, that actually works quite similar on both ends here. But now I can actually also add a second picture. So, and then you see,
even here, I think is very impressive because in most e-commerce sites or commerce solutions, when you pick a shirt, it might not necessarily show you the same pattern. I mean, just that fact, right? Like it will show you other similar shirts, but it actually succeeds to extract the certain pattern, certain color, but it's also not limited to only those features.
Yeah, exactly. All right, so now we have two images. And what we can do, we can basically say how much of each image we want to sort of pay attention to. So you can kind of blend them together. So now let's see what happens if we give it a little bit of palm tree more and then the shirt. And now it will basically create embeddings for both of them and then combines them. So technically it averages them. And then it uses that as the one it then uses for similarity.
This is really cool.
Yeah, so now we can actually see what happened here on the left side is that it really merged these concepts together. So it kind of figured, okay, there's a shirt and at the same time palm tree. So yeah, I guess I search for shirts with palm trees, so to say. So, and here that actually works pretty well on this side. Well, you see on the right side, it didn't, well, actually, I mean, it's much more subtle. So I think what happened here is you can still see they are all very close to the original one. However, here I think it mostly focused maybe on the color. And I mean, this was already blue, so it probably just made it even more blue, so to say. So that is.
But for sure, the clip one seems to be smarter.
It depends what you want in the end. So if you want something where it's very much, for example, I mean, sometimes you could also use this here to really identify a particular style. So let's say, okay, you have an image, and now I want to find another image with exactly that style. That is a bit what we will talk later about shop the look, these kind of things, where you need that attention to detail, really. And that is, I think, where this is better. This is more, let's say, the fun model, because it connects more, I think, how we think about things, the world in general.
But I also think one can create a quite exciting experiences doing this. For example, you could be offered like, here's a set of products. What is your liking? You would start off by saying, I like that and this and that, and you will get basically more of these, like the average of those. So you might say, I like this short dress, however, I like it with floral prints, right? So now you're actually getting many more short dresses with floral prints. So it doesn't have to be this extreme of picking like a palm tree. It can basically be picking multiple different type of styles.
Exactly. When it's sort of like a recommendation system based on, okay, I like these things, I don't like those things. Now you put that all together, and then it might show you something
Exactly.
in the
And then
direction you're looking for.
yeah, and then combining it with like best selling, so you could have more of a recommendations on hard facts, like what is trending, what is best selling, and then say like you find the top 3, and then you say more like these.
Exactly. I mean, in the end, when it comes to actual recommendations, I mean, usually you also tend to combine several things together. So it's about similarity, but then you also factor in maybe other things, as you just mentioned. Yeah, but let's maybe even double down on this. So here I have another image. This is now a coconut. And we do the same thing. And then we see what happens. All right, there we go. So actually didn't change too much. So we still see palm trees and the shirt. Actually, I haven't checked, but I also doubt that we really have shirts that show coconuts in the database. However, if you think about it, it still makes sense, so to say, because the coconut on the palm tree, so it still made that connection, sort of. Okay, coconut, and so palm trees are still valid because they're also very close to coconut conceptually. So that's why on the left-hand side, we still see shirts with coconuts. While, yeah, on the right side, again, nothing really changed here too much.
What would happen if you would go much more right on the coconut on the slider?
Oh, yeah, that is good that you say it. Actually, that's also super interesting. So if I do this, then something else will also show up here. Yeah, voila. So actually, the left-hand side didn't change too much. So you still see basically these palm patterns. However, here now you see suddenly heads. And again, makes sense because this here doesn't really think about, okay, is it a coconut, is it a head? It more thinks, let's say, about shapes and colors. So now this coconut really resembles, or you could see it, that it resembles basically this head, for example. Also here, it tries to match more sort of in a kind of literal sense, the image. So it tries to find images that also have somewhere here a bit of ocean and then here a bit of sand. And here, I guess it took the straw for the palm. So this is how it, on that level, sees the connections here. Also here, it sees the straw and, I mean, the shape again. So the coconut sort of and the straw resembles the layout, let's say it like that, the layout of this image more.
Got it.
So that is very much the difference between both sides. And then pretty much similar to this is, or I mean, the difference here is it's more kind of a scene, but I mean, again, we have a person, and of course that person is now also wearing things. So if we now look at the results, then it becomes a bit more nuanced, but you can, I think, also here see that on the left-hand side, I mean, if you look at the first image, I mean, the clothes, they don't really have too much to do with that one, but it's more, let's say, the concept again. So kind of rocker style, especially the sunglasses it picked up on. Also here, I mean, leather jacket, although there is no leather jacket, but it kind of connects leather jackets with rock and roll, I guess. So that's why it kind of makes these connections here. While on the right side, it's more, yeah, it tries to resemble the image as such. So again, the colors and the shapes, these kind of things. So this is also
Yeah, but
again, I
there
think
is
good
it's very, very obvious that it has a certain direction. It figured out like this coolness factor in different ways.
Mm-hmm. Yeah, exactly. I think one reason why I brought up this one in the end is I think it's also then a good transition maybe to one of the next episodes. Of course, if you now look and think, okay, I mean, actually, there's this T-shirt, but I mean, obviously, I think we don't even have that exact T-shirt, but still, maybe you would expect to see some T-shirts like this in the results. And I think
Mhm.
on each side, you don't really see that.
Mhm.
And that is a bit the issue
Mhm.
with embeddings on a whole picture that, well, of course, this embedding has to somewhat describe the whole picture and it does not necessarily know kind of what you're focusing on.
Mhm.
So, of course, now we are in fashion. We probably are more interested in the clothes, but the embedding also has to think about the flag and the background, etc. So it includes basically everything. And if we want to do something more, okay, I really want to find this T-shirt. I mean, that is then exactly where we come into the topic of shop the look. So basically, find me the things in the image. So
Exactly, and that is something we'll cover in the upcoming episodes.
yeah.
But it's what I really uh, enjoying with similarity search or visual search, because again, you provide something visual and you expect it to make a search on that embedding. Now we know that, but
Mm-hmm.
and then it returns something visual. So visual in, visual out,
Mm-hmm.
and it's really performing well in terms of what a user would expect and maybe even beyond. And it's also like uh, possible to commercialize it, which we have done in our in-store solutions, and we're building it more into more applications. So we should also probably mention that this is a feature that Touchtech do have in their platform. Again, can provide it to any third party that would like to push in the data to our AI service and then make these queries. And we've also made, maybe you can talk to that a little bit, Stefan, to really make it performant, to make it actually execute both when we get new products, because they are updated as new collections are being released, and they have to be processed and made sure to be available to search on, right?
Mm-hmm. Exactly. As you already saw, I mean, just creating these kind of embeddings can take a bit of time. So that is what we usually do upfront. So whenever there's a new product coming in, then we look, okay, what are the images? And then if it's a new image, then we do that kind of processing, and then we remember that embedding for later.
Do we do
Um,
that processing on
mhm.
each image? I mean, side, back, front, bottom, model shots, pack shots, and so on?
Yes, absolutely. So we take every image that we get, and then we do a lot of different things. I mean, last time we talked about classifiers, so we run several classifiers on them. But then we also create different kinds of embeddings, and actually we create both embeddings here because they, I mean, as you saw, I mean, both can have their purpose. So some are better for some things, some other for other things. So that's why we use both. But then the good thing is you can sort of remember them in a database. So because they don't change. So as long as the image doesn't change, those embeddings won't change. And then you just store them. And nowadays, because these kind of searches on embeddings are becoming extremely popular nowadays, so there are even databases, they're optimized for these kind of things to make it um, then also much faster to do these kind of comparisons in the end. Because of course, if you might have, let's say, extremely like 100,000 of images you need to compare with, um, ideally, of course, the database is also optimized for these kind of things. But there are a lot of different solutions for this nowadays. I think we can probably also put some in the links, maybe as a starting point, if somebody's interested in that.
Amazing. Cool. Anything else, or is this a wrap?
I think it's a wrap.
Cool. I think this is one of the more visually appealing demos, and also the basis for what we will showcase in the upcoming episodes. So stay tuned.